Alright, and now time for the little extra bonus. Let's plot the decision tree. So in order to have the best interpretation, we're going to remove the feature scaling. And to do this, we're going to clear everything and re-execute the code, but without feature scaling. So let's do this. We're going to clear the data here by clicking on this button here, and yes. Then clear the plot here, yes. And then clear the console as well by typing Ctrl-L. Here we go. All right, now everything is clear. We can re-execute the whole script. So let's do it step by step. We're first going to take all the pre-processing step, but without the feature scaling here. As you can see, I'm not selecting this. All right, so now Command and Control plus Enter to execute. All good. Now you can see that if we go to our data set, training set, and test set, you can see that the features are no longer scaled. All right, so for example, in the training set, we have the real age, with their real values, and the real estimated salaries, the real values. Okay, so nothing scaled now. Let's select this to fit the decision tree classifier to the training set. So Command and Control plus Enter to execute. Here we go, now it's fitted. By the way, I'm just going to replace this by decision tree classification. All right. What we're really interested in right now is to plot the decision tree. So we're going to add a new section here below, and I'm going to call this section plotting the decision tree. And as I told you in the Python tutorial, this is going to take 2 lines. This is very simple, so let's just do it. It's going to be very quick. Okay, and besides, the 2 lines that we need to write could not be more simple, because indeed what we need to type here is plot, and then in parentheses, classifier. Because the classifier here is the classifier that we created here in this part, using the rpart function of the rpart library. And that's all. We just need to type plot classifier, and that will plot the tree, but without the labels, without the conditions written explicitly. So in order to add these conditions written explicitly, we just need to add below text classifier. Here we go. And now it's ready. Isn't that simple? These only 2 lines will plot an interpretable decision tree. Let's check it out. I'm going to select all this and press Command and Control plus Enter to execute. And here is the tree. So as you can see, we have at each split the condition that is generating the split. So for example, the first split is made based upon the condition age lower than 44.5 years old. So that means that if the user is below 44.5 years old, he will go to this subcategory after the split. And if the user is older than 44.5 years old, he will end up in this subcategory of the split. And then we have some new conditions. So here, a new condition on the other independent variable, the estimated salary, and this condition is estimated salary below $90,000. So what that means is that if the user is younger than 44.5 years old and has an estimated salary below $90,000, then according to our decision tree classifier, this user won't buy the SUV because the result here is 0. And if the user is younger than 44.5 years old and has an estimated salary over $90,000, then according to our decision tree classifier, this user will buy the SUV because the result here is 1. Okay, and if we go to the other side of the tree, well, this other side of the tree first contains all the users that are older than 44.5 years old. And then we have some new conditions generating new splits. So another condition on the age here, then another condition on the estimated salary, and then again another condition on the estimated salary. And following yes or no these conditions, we end up in some final categories, the final nodes of the decision tree, where the user is predicted not to buy the SUV for this node and predicted to buy the SUV for this node and this node and this node. Okay, so that was worth looking at this. We sort of explored this decision tree classifier behind the scenes, And what's important to understand now when you are using decision trees is that a big advantage of this classifier is that we can have these very interpretable results, because here on this decision tree plot, we can see everything that's happening. We can see how the decision tree decides whether a user will be predicted to not buy the SUV or to buy the SUV. We clearly see the whole thinking process of the decision tree. And in some way, we saw how it learned from the data how to classify each of our users of the social network. All right, so I look forward to seeing you in the next section about random forests. We will implement random forests on Python and R, and I can't wait to show you the final graphic results. Until next time, enjoy machine learning.